All right, let's get into it. Today, we're going to pull back the curtain on one of the most powerful and, let's be honest, most misunderstood technologies out there: artificial intelligence. You hear the term AI thrown around all the time, right? It's in the news, it's on your phone, but what does it actually mean? It can feel kind of fuzzy. So let's cut through all that noise and get to what's really going on. So, think of this as our map for the whole AI universe. Artificial intelligence, or AI, is the big picture, this huge, sprawling field. But the real powerhouse, the engine that drives almost everything we call AI today, is that smaller circle inside: machine learning. And that's what we're going to dive into. So let's pop the hood and really take a look at that engine. What is it about machine learning that makes it the absolute heart of modern AI? Okay, this is the big idea, the total game changer. For years, programming meant giving a computer a super detailed, step-by-step list of instructions for every little thing. Machine learning just flips that whole idea on its head. Instead of us writing the rules, we just give the computer a ton of data and tell it, you figure out the rules for yourself. So the huge question is, how in the world does a machine learn? I mean, it sounds kind of like magic, but it's really not. It's actually a pretty logical process, and we're going to break it down right now. To make this feel real, let's use a super common example: teaching a machine how to guess the price of a house. It all really comes down to this four-step loop. First, you collect data. I'm talking thousands of examples of houses, with all their details, and crucially, the actual price they sold for. That's the right answer. Then, the model makes a guess, a prediction. Now, step 3 is the important part. It calculates the error. It looks at its guess, compares it to the real price, and sees how wrong it was. And finally, it uses that error to adjust its own internal logic, just a tiny bit, so it can make a better guess next time. Now, imagine it doing this not once, but millions and millions of times, getting a little bit smarter with every single try. But, just like a human student, a machine doesn't always get it right on the first try. It's not just about learning. It's about learning the right thing in the right way. And this leads us to two classic problems. On one hand, you've got overfitting. This is like that student who just memorizes the answers for the test. They can ace the practice questions, no problem. But the second you give them a new problem they've never seen before, they're completely lost. On the other hand, you have underfitting, which is like the student who just didn't get the lesson at all. The model is just too simple to even find the basic pattern. The real art of machine learning is finding that perfect sweet spot right in the middle between memorizing and not learning enough. Now, that whole learning process we talked about, it can be applied in a few different styles. First up is supervised learning. That's our house price example. You give the machine the data and the answer key. Then you have unsupervised learning. That's where you just dump a bunch of data on the machine and say, find some interesting patterns in here for me. Think of it grouping customers together based on what they buy. And finally, you have reinforcement learning, where the machine learns just through trial and error, getting rewards for good moves and penalties for bad ones, kind of like a robot learning to walk. Okay, so we have these incredibly powerful ways for machines to learn. But what kind of intelligence have they actually created? Let's zoom back out and look at the big picture, the entire landscape of AI as it actually exists today. This is probably the most important thing to understand about AI right now. Every single AI that exists today, and I mean everything, is what we call narrow AI. It's absolutely brilliant at one specific task, and that's it. The sci-fi version of AI, the one that can think and create like a human, is called general AI, or AGI. And that is the goal, the holy grail of the field, but for now, it's still just a goal. Another way you can look at all this is by an AI's actual abilities, on a kind of sliding scale from the really simple machines of the past to the theoretical minds of the future. So let's do a quick trip through that evolution. First up, you've got reactive machines. These are the oldest kind of AI, and they have zero memory. They can't use past experiences to change what they do now. The classic example here is Deep Blue, the IBM chess computer. It could analyze the board and find the absolute best move, but it had no memory of the previous moves in the game. It was always starting fresh. The next step up is limited memory AI. This is where pretty much all of the AI that we use today lives. These systems can look into the very recent past to help make decisions. Think about a self-parking car. It's not just looking at the parking spot right now, it's also tracking the speed and direction of the cars around it for the last few seconds to make a safe move, or even your streaming service. It's using what you just watched to recommend what you should watch next. Okay, now we're jumping into what's next. Theory of mind. is the next big frontier. We're talking about an AI that could actually understand that humans have feelings, beliefs, and intentions, and that those things change how we act. This would be a massive leap, and it's something researchers are working on right now. And finally, we get to the ultimate way out there stage, self-awareness. This is an AI with real human-level consciousness, a sense of self. To be super clear, this is purely hypothetical. We are nowhere close to making this a reality.
So, from a simple chess computer all the way to a conscious robot, it's pretty clear that our own definition of what makes a machine smart is always changing.
And that brings us to this fantastic idea, which is summed up perfectly by this quote. AI is everything that computers cannot currently do. Artificial intelligence is a moving target. And isn't that so true? I mean, think about it. Just a couple of decades ago, a GPS that could plot a route across the country in seconds would have seemed like magic. Now, it's just a normal app. The second we figure out how to do something, it stops feeling like intelligence, and it just becomes, well, technology.
And so that leaves us with this final, really interesting thought. As that target of what AI is keeps getting pushed further and further by machine learning, what are the things that seem like pure science fiction today that are just going to be another app on our phones tomorrow? What's next?